Thanks for watching this screencast. The objective of this screencast is learners will be able to use the imaginary unit I to evaluate square roots of negative numbers. So we need a little bit of a backstory here. Which numbers have square roots? Up until today, on the number line, here's one that definitely does. 1 has a square root. The square root of 1 is 1. In fact, I think you could say that 4 has a square root. The square root of 4 is 2. What about 2, though? Well, it does. 2 has a square root. The square root of 2 is just an irrational number. It's about, I should have made that the about equal to 1.414 something, I don't recall. So even the positive numbers that are not perfect squares have square roots. But even all the positive real numbers do too. If I were going to indicate on the number line which numbers have square roots that we know about before today, it would be anything that's positive or even 0. Because the square root of 0 is 0. So anything here, including irrational numbers, including not perfect square integers, anything from 0 including 0 to infinity has square roots. But the numbers over here don't. There's no real number that you could use to find the square root, for example, let's do this one, for example, of negative 4. Like what number could you square and get negative 4? There is not a real number that solves that. We're going to change that today. So here is a problem and a solution. The problem is that not every real number has a square root. If I go back a page, only the positives and 0 have square roots. We can't find square roots for negative numbers. That's the problem. So here is the solution to the problem. Let's choose to create a value for the square root of negative 1. And let's give it a name. Let's name it. We're going to call it I. And I is known as the imaginary unit, where by definition this I is the square root of negative 1. And what that solves is that now we can find a square root for any real number, positive, 0, or negative. Okay, let me show you a couple of examples of specifically how that helps us. We want to find these square roots. Now, before we invented I a minute ago, these were impossible to find. But now I can. I can find the square root of negative 64. What I want to do is I want to think about breaking this radical down into products, a product of things that I know how to find the square root of. And I see that I could break this square root of 64 into two things that I know how to find the square root of. I could call that negative 1 times 64. So I know how to find the square root of this, and I know how to find the square root of this. And a property of radicals is that the square root of a product is the same as the product of their square roots. So if I want to simplify the square root, well, I know what the square root of 64 is. That's 8. And we just defined the square root of negative 1, I. So 8 times I is the square root of negative 64. Now there's something slightly different about the square root of negative 20, and the difference is that I can't turn every factor of negative 20 into something that has a nice square root. So my goal is going to be to separate out the things that do have nice square roots and simplify it as much as possible. So I know that the negative can be written as negative 1. And now I want to think about the 20. And I want to think about the biggest perfect square that goes evenly into 20. And what I hope you see is that 4 is the biggest perfect square that goes into 20. And then it goes into 25 times. So again, I'm going to identify that I know how to find the square root of negative 1. And I know how to find the square root of 4. And 5 doesn't have a nice square root. It can't be simplified. So what I can do is I can say, well, hey, the square root of 4 is 2. The square root of negative 1 is I. And unfortunately, I can't do anything about square root of 5. That needs to be part of my answer. So the square root of negative 20 is 2i, with I being the square root of negative 1, times the square root of 5. Okay, at this time you should pause the video. On scratch paper or somewhere off to the side, you should try these two items. And when you think you've got the answers, hit play and we'll check it out. Let's see how you did. To simplify the square root of negative 49, I hope you either wrote out or recognized that negative 49 could be written as negative 1 times 49. And we know what the square root of both of those numbers is. The square root of 49 is 7. The square root of negative 1 is I. So the square root of negative 49 is 7i. The square root of 32 is not the opposite of a perfect square, but I can write negative 32 as negative 1, which we know the square root of, times, let's see, what's the biggest perfect square that goes evenly into 32? Yeah, it's 16. And then there'd be a 2 left over. And we know the square root of 16 is 4. We know the square root of negative 1 is I. And square root of negative 2 is unfortunately not going to simplify. So how about an answer of 4i times the square root of negative 2? Thanks for watching.